Good afternoon. Let's begin the lecture for this afternoon. Just to remind you, we are gonna have our second exam on Wednesday next week. So a week from today, we'll have our second exam. So Monday, we're gonna have our review. In the review, I'm going to discuss the format of the exam. But if you want to start preparing for the exam, best thing you can do is to start looking at the assignments and the labs that have been covered after the first exam. Also look at the notes, and the video lectures are available in case you want to rewatch the material. So everything is available. The solutions are also available, and you will be getting feedback before the end of the week for the assignments and the labs that you have completed so far. So by the end of this week, you will get the feedback for those assignments and labs. Any questions? Yes. Yes, so the solutions should be available already for most of the assignments. I think if you go to the modules, they should be there. If you don't find, I mean, if you submitted something already and you don't find the solution in the modules, let me know. Good question. So in terms of the material for this second exam, we're gonna cover the rest of lecture 7 today, and then we're gonna start lecture 8, and then that will be the end of the material that will be covered for that second exam. On Monday, we're gonna focus on the review and to answer questions. So we might go over the assignment problems and also about the topics that will be included and so on. So in our previous lecture, we started discussing how to compute the number of machines that are needed for a department according to some specific parameters, including the standard time for producing a part, the number of units to be produced per shift, the actual performance of the machine, the amount of time available per machine, and the reliability of the machine. So we cover one example, and then I ask you to complete the lab exercise. So I kind of guided you in this problem. The only difference in this problem, when you compare to the previous one, is that in this one we have some defects happening in each one of the stations. So before we compute the number of machines that will be needed for each station, we needed to know what will be the actual number of units that you needed to produce in order to get the actual value, which is the 10,000. So we went through that process. I actually stated the equations here. So if you needed to compute those values, let me set up the numbers here. This was 10,000 over 0.95 times 0.95 times 0.97. So that was 11,423 units. And then here, this was 10,000 over 0.95 times 0.95. And this was 11,080. And for A2, we have 10,000 over 0.95. So this was 10,526 units. So for FB, this was, since we already know the value for Q when computing this input for the second station, we can substitute that value. You're gonna make IK equals QK now. So for B, that value is 10,000, I'm sorry, 11,080 times S was 3. H, we computed H as 1,000, I'm sorry, 2,880 minutes. And then the efficiency was 0.95 and the reliability was 0.95. So for station B, we end up having 12.79 machines, which we round up to get the 13. Then for FA, we have 2 stations that are requiring machines of type A. So we have the combination for the first station A1 plus the combinations for the second station A2. So for this one, let's see if I can write that here. It's 11,423 times 5 divided by 2,880 times 1.08 times 0.98 plus 10,526 times 3 divided by 2,880 times 0.9 times 0.95. And that summation is 31.57. It's about 32 machines. Okay, any questions? Yes. For when you compute FA separately, is that what you're referring to? Oh. Oh, okay, I got you. So here for these units, that's yeah, so you're gonna round up basically, yes. Because again, 1.5 units, you will not be able to build 1.5, so you will go to the next number, yes. Good question. So at this point, this is the solution. So we have one more thing to discuss, and it's the machine assignment problem. And now that we know how many machines we need for the area, the other question that we need to understand or we need to answer is how many people will be in charge of this number of machines. Okay, so for example, you need a staff member to go set up the product, and then after the product is completed, take the product out of the way, and then continue that process. So if you have one machine, that person will be in charge of the process. If you have multiple machines, you see that there will be some instances in which this person is not going to be able to take care of both machines at the same time or both lines at the same time. So there will be time periods in which the machine will be busy and will be idle, waiting for this person to come up and set up the next batch and so on. So we need to have an understanding of, if we have these many machines, how many people at least we need to manage the operation of these many machines. So in this section, we consider how decisions regarding the assignment of machines to operators can affect the number of employees. Specifically, we consider a situation involving the assignment of operators to semi-automatic production equipment. It is assumed that the machines are identical. So to illustrate the situation, we have a figure on the next slide, which shows the activities of an operator in 3 machines. Okay, so in this figure, we have the timeline. On the first column, we have the operator activities on the second column, and then we have the activities happening in each machine as time moves forward. So we start with the first machine, and you'll see that basically what this figure is trying to illustrate is those time periods in which you have these machines idle, waiting for the operator to arrive. So if we start with the first machine, the operator will start at time 0. So he can only load, if we have only one operator, he can only load one machine at a time. So he'll be loading machine 1. And as he loads this machine, you know that the other machines will be idle, waiting for the operator to start them. So this is what this time period is representing. And then the operator will need some time to travel or to walk to the next machine. So this is what this traveling period is showing. So after the first machine is loaded and the operator gets to the second machine, he can start this process. But after that, he has to travel to the third machine and then start the third machine or loading the third machine. So as you can see, having only one operator is causing these 2 machines to be idle for a long, let's say, for some time. And then once it's the processing start for all the machines, you'll see that the operator will go back to the station, and he'll be idle for some time until this machining is completed. And then the process is started again. So he has to go unload and load the first machine. By that time, these machines will be completing the machining. So it will be idle until the operator goes to the machine again. Third machine will be idle until the operator goes to third machine. And by that point, the operator actually would not have any other idle time. So because by the time this one is loaded, this one is completed, and he will have to go unload, load again, unload, load again, and so on. So the question we're trying to answer is, knowing that we have these many machines, how many operators you should have in this system. You have to find that balance between not having the machines idle for long periods of time, but also for having the operator, well, and also looking at the operator and not having the operator for a long period of time idle. So how do you find that balance? So this equation that we're gonna study today will try to accommodate and give us an idea of how many operators should be assigned to each machine. So under the conditions similar to those depicted in this figure, a deterministic model can be developed to determine the optimal number of machines to assign to an individual operator. So we have the parameters associated with this model. We have A, the concurrent activity time, which is basically the loading and unloading of a machine. B is the independent operator activity, which includes walking, inspecting, packing. T is the independent machine activity time, which is basically the machining time for each machine. N prime is the ideal number of identical machines to assign an operator. M is the number, which is what we're gonna compute. M is the number of identical machines assigned to an operator. TC is the repeating cycle time. IO is the idle operator time during a repeated cycle. And IM is the idle time for each machine during a repeating cycle. So having a figure like this one can help us identify those values. So excluding the idle time or excluding idle time, each machine requires A plus T minutes to complete a cycle. Likewise, operators devote A plus B minutes to each machine during a cycle. Hence, an ideal assignment is given by this equation. N prime equals A plus T divided by A plus B. For the example, A equals 2 minutes, B equals 1 minute, and T equals 6 minutes. Therefore, for that case, N will be equal to 2.67 machines. Since the fractional number of machines cannot be assigned to an operator, consider that what will happen if some integer number of machines, M, is assigned. So now we're going to look at what will happen if we assign 2, what will happen if we assign 3, if we go up or down in this number 2.67. So the work content for operator will total M times A plus B, while a machine cycle will be A plus T in duration. The repeating cycle will be the larger of the two, and the difference in the two will be the idle time. If M is greater than N prime, the repeating cycle will be M times A plus B in duration, but if M is less than or equal to or less than N prime, then the repeating cycle will be A plus T in duration. Therefore, we can state this mathematically. So TC, which equals the repeating cycle, will be equal to the following. It will be equal to A plus B for M less than or equal to N prime, and it's going to be equal to M times A plus B for M greater than N prime. IM is the idle time for each machine. that's gonna be equal to 0 if m is less than or equal to n prime, and it's gonna be equal to Tc minus a plus t if m is greater than n prime. I0 will be equal to Tc minus n times a plus b, for m, commas here, for m less than or equal to n prime, and this is the operator idle time. And 0 if m is greater than n prime. So essentially what this is trying to show, like if you look at IM, the idle time for each machine, that will never happen if you have more operators than machines. So this is 0. Okay, so what this is saying is n prime is the number of operators assigned to machines. And if you have more operators than machines, or at least the same number of operators in machines, then you can assign each operator a single machine, and you know that the machine will never be idle because you have an operator always assigned to that machine. But in the case that you have more machines than operators, which is this case, then you will have an idle time for the machine. And that idle time will be equal to Tc minus a plus t. If you look at the operator idle time, is the same thing. If the number of machines is greater than the number of operators, these operators will never be idle because they will have to take care of all these machines. And at the time that they're finished with one machine, the other one will be waiting for them to arrive. But if the number of machines is less than or equal to n, then these operators will experience some idle time, and that idle time is given by Tc minus m times a plus b. So question is, which way you want to go? You want to keep your employees always busy, or would you give them some idle time for them to rest during the work shift? So based on your strategy, you can find the right balance. What I would do is I would plot this into a graph, and I will try to find the break even in which they have some time available, and but not too much that they will be idle for a long period of time. So that will be the conclusion. So the equation will be n prime equals a plus t divided by a plus b. So again, that will give you most of the time you will get a fractional number. So the question is, for example, in this problem, we get 2.67. So the question is, would you go up in which you want to go to 3 and you will keep your operators always busy? Or if you go down to 2, that will give the operators some idle time, and your machines will be always running, which is an advantage. But you will have to pay for that additional operator and so on. Any questions? Okay. So this concludes our discussion on this topic. The next material is a little bit more descriptive in terms of what we're going to do is just introduce some equipment that is commonly used in facilities, manufacturing facilities, warehouse facilities for material handling. So if you saw the lecture, this is a very long lecture. Obviously, I'm not going to go through the 100 slides today, but we're going to go at least halfway through this lecture today. And the idea is just to get you to at least learn about the different type of material handling equipment available in manufacturing facilities, and that you can put a name next to that equipment, and you can familiarize yourself with these different equipment available in material handling and facilities. So so that will be connected to our first objective, to develop an understanding of the principles of facilities location, layout, and material handling system, and practice design facilities. And the agenda, just gonna give you an introduction, and then we're gonna go over this list of equipment. I'm gonna show you, give you some examples of how those are used, and so on. So we're going to learn about some of the material handling equipment requirements into a facility. So if you remember that first lecture of the semester, I think I showed you this figure. We were going to talk about facilities planning, and one of the areas that was listed was handling system design. So today we're going to look at some of that in this lecture. We have already looked at structural design, layout design, and now we are going to talk about handling design. In the third part of this semester, we're going to look at facility location at the top. So components of material handling. We have three components: the materials, which are the stuff that we're going to be moving inside the facility, products, items, substances, and or people, which are being moved, transported, or physically relocated within the facility. We have the move, which is what's going to help us take these materials from one point to another point, which includes the origin, the travel path, destination, frequency, or the move to be made. And then the third component is the method. So equipment, people, procedures, physical facilities to be used to make the move. So at the bottom of this slide, I have what I call the material handling equation, in which we have the three components: material plus move equals the method that we are going to use. And in order to identify each one of them, you can use these questions. So for the material, basically is what you're going to be moving. For the move is where are you going to move this and when. And then the method is how are you going to do that and who is going to do that. So by answering these questions, you can identify the material, the move, and then also decide the method. All of them together is the why. So we have a taxonomy for material handling equipment. This is the source is the College Industry Council on Material Handling Education, and we have the committee name, and the material handling equipment is basically classified according to this council. So we have transport equipment, which includes conveyors, cranes, industrial trucks, or not equipment at all, which means that the person is going to be moving that from point A to point B. And between that, we have positioning equipment, unit load formation equipment, storage equipment, and identification and control. So material handling equipment is used for the movement and storage of material within a facility or a site. And material handling equipment can be classified into the following 5 categories. The first one is transport equipment, which is equipment used to move material from one location to another location. And there are 4 major categories or subcategories of transport equipment. These are conveyors, cranes, industrial trucks, and material can be also transported manually using no equipment. So again, a person moving this from point A to point B. So that's the first major category. The second one is positioning equipment. And this is equipment used to handle material at a single location so that it is in the correct position for subsequent handling, machining, transport, and storage. Unlike transport equipment, positioning equipment is usually used for handling at a single workplace. So the idea is you have, for example, a table, and then you're getting this product into your table, and you have an equipment that is going to allow you to position that so you can proceed with the next steps on the process. Material can also be positioned manually using no equipment. We have the unit load formation equipment, and this is equipment used to restrict materials so that they maintain their integrity when handled as a single load during transport and for storage. For example, pallets and so on. If materials are self-restrained, for example, a single part or interlocking parts, then they can be formed into a unit load with no equipment. Number 4 is the storage equipment. This is used for holding or buffering materials over a period of time. Some storage equipment may include the transport of materials. For example, the SR machines of an ASRS or storage carousel. If materials are block stacked directly on the floor, then no storage equipment is required. Identification and control equipment. This is used to collect and communicate the information that is used to coordinate the flow of materials within the facility and between a facility and its suppliers and customers. Identification of materials and associated control can be performed manually with no specialized equipment. Typically, you have an RFID scanner and RFID codes that are in the building, and that keeps track by using the scanners of the location, and to also to transport if you are using automated guided vehicles to learn where to go with that material. So between transport or in-transport equipment, the major subcategories of transport equipment are conveyors. So this is equipment used to move materials over a fixed path between specific points. So if you go to an airport, for example, you put your luggage in this inspection carousel, that's a conveyor. So you put your luggage there, it's going to be moved over a fixed path between specific points. The cranes is equipment used to move material over variable paths within a restricted area. Industrial trucks, also equipment used to move materials over variable path. So there's no a constraint or fixed path that you have to use, with no restriction on the area covered by the movement. And then again, no equipment. This material can also be transported manually using no equipment. So this is illustrating the difference between a conveyor, a crane, and an industrial truck. So for a crane, you will have a variable path, but you also have a restricted area, which is illustrated by that deep blue constant area in the figure. And then the industrial trucks have a variable and unrestricted area. So you can see that the area covered by those lines is larger than the area covered by the cranes. So variable path and unrestricted area. And then the conveyors are illustrated by that red line. Basically, they have a fixed path, so they have to follow that path every time, going back and forward. Or actually, they go in one direction most of the time. So conveyors are used when material is to be moved frequently between specific points. Like as I mentioned, for the airport, you know that the luggage is going to be moved in the same direction throughout the day. So you put your luggage, it's moved through the scanner, and then at the end, someone pick it up and move forward. So that's why conveyors are used in airports and in manufacturing facilities. That will be also the case. So if you have a production line in which you know the product will go start in one point and go through the process and finish at the end of that sequence, then conveyors are probably the best way to go. So material is to be moved frequently between specific points and to move materials over a fixed path. And when there is a sufficient flow volume to justify the fixed conveyor investment. So conveyors are expensive. So you have to make sure that you have a high volume of items being moved in the same direction for a long period of time. Conveyors can be classified in different ways based on type of product being handled, if it's a unit load or a bulk load, location of the conveyor, and whether or not loads can accumulate on the conveyor. So here's a list of different type of conveyors. As you can see, it's very, very long. So we're gonna show some pictures about them, some of them. We're gonna compare them on the next slides. So as you can see here, I've seen this frequently. Like if you, I don't know, if at some point you volunteer in these food banks, they have some of these wheel conveyors to move their produce and boxes when they go and distribute this to communities, and when they receive the items at the facility. So wheel conveyors are pretty common. They provide that flexibility that you can store them and then open them when needed. So the wheel conveyors, the idea is that you have those wheels, and when you push the items, they will move fast. So you need a person to help you move those through the conveyor. And then you have the chute conveyor here, which is common in, for example, companies that are dedicated to shipping. So for example, if you go to one of these, I went to UPS warehouse, which they have the trucks waiting for distributing packages. You will see these conveyors frequently. So boxes are saying, okay, this box going to San Antonio, this box going to Austin, and a machine will put the box, push the box through the chute, and it will get to the area of the truck. More conveyors here. Chain conveyor, gravity roller conveyor. This is a power conveyor, so you have a belt. This is similar to what you have under the supermarket conveyor. So you have basically a power that is going to move that belt when needed. The slack conveyor, also typical on those UPS, FedEx warehouses. So once you know where the package is going, it will going to move the ramp at some point to separate the packages. Magnetic belt conveyor, these are not very common, but I guess there's some specific industry in which you want to separate your materials. So having a magnetic belt will allow you to do that. Flat belt conveyor, transport equipment conveyors, vibrating conveyors, again, for packaging. In this case, French fries, want to have specific amount on each lane. So that vibration allows you to separate the product. And the bucket conveyor, so basically pulling everything up so you can discharge the amount you need in these areas. Transport equipment conveyors. This is the dilute phase pneumatic conveyor. I have not seen this one in reality. I have seen this one, the screw conveyor, again, moving on materials, and this carrier system pneumatic conveyor. This is what you're gonna see like in a car service in the, let's say, banks or financial institutions. You go, you put your information or whatever you need to do, paperwork, and it will get transported to inside the facility. Transport equipment, vertical lift conveyors. So this one has a specific space, so you can only move, for example, here, a single unit. Basically keep the rate of flow between these two areas, so you always know that you will get one package at a time. And then the cart on track conveyor, and this gives you some flexibility in terms of movement. It's same thing here. So this is common, let's say, in warehouses in which you have to store materials frequently. Transport equipment conveyors. This trolley conveyors, again, has a specific capacity, so you know how much you're transporting, so it kind of keep your flow constant. And so there's two here, and the town conveyor. More examples. You have a power free conveyor, same thing, similar to trolley conveyor here, some on power, some on power. Sortation conveyor. So again, this similar to what you're going to see, let's say, in airport when separating the luggage, knowing which luggage will go to a specific airport. So that's why you need a conveyor, and also you have these machines that are basically scanning where to go, the next luggage where it goes, and depending on that, then they are going to be separated through the sort subsystem. And that could be many ways. So here you have a different ways of separating the packages. So this thing is going to be moving according to where this is going, this direction or this direction. Or you have these pushing machines that if the part is scanned and needs to go in this direction, they will push that through the conveyor. More examples, different type of movement. So again, the same idea. If you have to move in one direction, you have that flexibility. So even though you have a fixed path, you have the flexibility of choosing paths within the conveyor. Timing belt and cross belt transfer device. These are a little bit more specific in terms of applications. So I cannot come up with a specific application for these two, but the idea again is they give you the flexibility of choosing a specific path for your product. Here you have units separated, let's say, per space. So that also keeps your flow constant. If you need to separate the packages like one per space, And then when you get to this point, they are sent to different locations according to their destination. Okay, so that's in terms of conveyors. Let's talk about the cranes. General characteristics of cranes that are used to move loads over variable, horizontal, and vertical paths within a restricted area. Used when there is insufficient or intermittent flow volume such that the use of a conveyor cannot be justified. Provide more flexibility in movement than conveyors. Provide less flexibility in movement than industrial trucks. So conveyors, again, high volume, fixed path. You want to go from point A to point B. So if you need more flexibility, then you can transition to a crane or to a industrial truck. The second level will be the crane. Loads handled are more varied with respect to their shape and weight than those handled by a conveyor. And most cranes utilize hoists for vertical movement, although manipulators can be used if precise positioning of the load is required. So here's a picture of a crane. Cranes are used to move materials over variable paths within a restricted area. And the major type of cranes are the jib crane, bridge crane, gantry crane, and the stacker crane. Okay, so again, you see you can move that material up and down, or you can move the horizontally or vertically. But again, you have a specific limited area. It's not that you can cover a big area. You have an area in which you can cover and you can move the stuff that you, or the materials that you want to move. So here we have different type of cranes. The jib crane is here at the top left. We have the hoist trolley here at the top and the pivot. We have the stacker crane. The idea again is to be able to move up and down and you stack materials accordingly. And the bridge crane that offers movement from left to right and up and down. So you can move this bar from point A to point B, and also you can move horizontally using that extra bar. Transport equipment cranes. So here we have some gantry cranes. So this one in particular is giving you the flexibility of movement with those tires. So you can move the crane in the place you need it. But most of the time, those are going to be fixed. So you have a specific area that are that will be constraining your movement. And then this is the last equipment that we're going to cover. So the industrial trucks. So industrial trucks are used to move materials over variable horizontal paths with no restrictions on the area covered. They provide vertical movement if the truck has lifting capabilities. And they're used when there is insufficient or intermittent flow volume such that the use of a conveyor cannot be justified, just as the cranes. Again, if you need to move for longer distances, then these trucks will be ideal. Like if you are moving materials or supplies from a dock to a warehouse, and then from the warehouse to you're moving those materials also from the warehouse to other areas, and then back to the warehouse, and then back to the docks. Having that coverage will be possible just with the trucks. The crane will not let you do that. A conveyor will be very expensive if you want to cover that long distance. They provide more flexibility in movement than conveyors and cranes, but they are not licensed to travel on public paths. Commercial trucks are licensed to travel on licensed public roads. So industrial trucks, here's the list of different type of industrial trucks. So the hand truck, like the dolly, those are common. See, if you need to move something at home, most likely that's what you're gonna use. Like if you need to move a refrigerator or another thing. The pallet jack, this you will see in the supermarkets. Walkie stackers, pallet truck, platform truck, counterbalance, lift trucks, narrow aisle straddle truck, narrow aisle reach trucks, order picker, side loader, tractor trailer, personal and burden carrier, and then finally the automatic guided vehicles or AGVs. These are pretty common now in applications like warehouses, like for Amazon distribution centers and so on. You will have all these AGVs moving the supplies from one point to another, and then bringing those to the picker or the person that is going to be putting together the box, and so on. So here's some pictures. The two-wheel hand truck, again, pretty common. The floor hand truck, this also pretty common to move large boxes. And this type of trucks gives you some, I mean, if you need to stack a lot of boxes or supplies, you have these security gates that will allow them to keep inside the truck. In terms of pallet jacks, again, you be familiar with this. You will basically put this on their pallet and lift the equipment, and you will be able to move that pallet without problem. But it requires the operator to pull or push the materials. Some of them will be providing an area for transportation or some power. For example, this, I think you can sit in this one, so you don't have to pull. You have some power in this one as well. So power pallet jack, you will have, even though in this one you cannot sit, you have an engine that will allow you to press a button here, and you'll be able to move the whole thing. Industrial trucks. So these are the lift trucks. So again, if you are moving things from one point to another and also lifting, these are the trucks that you will be using. Some of them are designed for narrow aisles. So warehouses, if you have very narrow aisles and you need to move things from point A to point B and also up and down, these are common. Some of them will give you that flexibility in terms of the movement. So this will have the fixed fork, but this one will have more flexibility in terms of movement. So it depends on the application and what you're trying to achieve. Industrial trucks. So here's an example of a AGV. So again, these are automated vehicles, and they're following. If you look at the picture, the floor has some lines. Those lines are stating the track for the AGV. So they follow those tracks. And the movement is based on those lines. Let's see. Power industrial trucks. These trucks are used for moving either mixed or uniform load intermittently over various paths. Again, that's the flexibility. Or these paths can be somewhat random at the discretion of the driver. The paths are restricted to suitable indoor or outdoor surfaces. Industrial trucks provide not only a means of transporting materials, but also provide a means of accurate lifting and stacking. Appropriate tooling for the truck permits users to lift not only pallets, but a wide array of specialized loads. For example, rolls of carpet are easily moved via industrial trucks by replacing standard forks with a single tool. These trucks can be found in almost any manufacturing plant, loading dock, or warehouses. Internal combustion trucks have the advantage of outdoor use. They can lift 2,000 to 15,000 pounds, with some specialty trucks lifting up to 50 tons. They can lift up to 20 feet in height and can operate on gasoline, LP gas, or diesel. The Industrial Truck Association has classified the powered trucks into 7 classes. So we have those 7 classes there. Electric motor rider trucks, electric motor narrow aisle trucks, electric motor hand trucks, internal combustion engine trucks, internal combustion engine trucks with pneumatic tires only, electrical and internal combustion engine 2 tow tractors, and rough terrain forklift trucks. Each of these classes are divided into lift codes, and we can see the ITA pictorial model listing. In terms of power industrial trucks, the first 5 classes are the most common. And again, the detailed information is available in the ITA. Electric motor rider trucks are general purpose trucks and are used primarily indoors. And they can lift up to 6 tons and up to 18 feet in height. The aisles trucks or narrow aisle trucks are used in narrow aisle applications, and they are used primarily for storage retrieval in applications similar to AS/RS functions. They can easily lift loads of from 2,000 to 4,500 pounds to heights of 40 feet. Electric motor hand trucks are generally used in indoor applications and can handle loads of up to 4 tons. These trucks are perfect for situations in which material is to be moved from one location to another without the need for lifting more than a few inches. For example, this type of truck is commonly used in grocery store to move pallet loads of cans or boxes or to a display location within the store. Another convenience is that the operator can move among customers in the store safely and without obstructive views. And the internal combustion trucks have the advantage of outdoor use. They can lift 2,000 to 15,000 pounds, with some specialty trucks lifting up to 50 tons. They can lift up to 20 feet in height and can operate on gas or diesel. And they have the advantage of outdoor use. So here's some more detailed information per class. And the lift codes, this is just for your information. You don't have to memorize this. So in case you end up having to decide between different trucks, you can refer to these later. So class 2 electric motor narrow aisle trucks. For lift code, class 3 electric motor hand trucks. So we have 8 lift codes. For class 4, we only have 1 lift code. 3, class 5 lift code 4, class 6 lift code 1, and class 7 lift code 1. So here's the ITA pictorial model listing, again, very detailed. So you can see class 1 electric motor rider. Class 1 electric motor rider trucks with lift code 4. You see the difference between 1 and 4, 4 and 5. So the size and the truck itself is different. Lift code 6, class 2, lift code 1, and so on. More examples for lift code based on the class. You can see the difference. You can look at this one, a different location for those for the fork. Same here. These are all electrical, so electric motor class 3. Class 4, this right here is for internal combustion, so you can see the difference between the electrics. Right? They don't occupy as much space. So these are designed to move more weight. And there's here the ones that are outdoor. See these, and you see the tires and so on. They're different. So these are called class 7 rough terrain forklift and rough terrain forklift truck. And you can find more information about the different trucks in this web page. Okay, so I'm gonna stop here. Again, we have about around 90 something slides. So I know going through all of them at once is painful. So I'm gonna stop here and then we'll continue with this material after the second exam. And do you have any questions? Nope. So I'm gonna stop now and I'll see you guys on Monday. Is up to what we covered today? Yes, it's gonna be part of the exam. But these are gonna be more questions, let's say, for the true or false or multiple choice. So in which I can just ask you different classes or different type of equipment, but just to what we covered today. Okay. For example, when would you use a crane? When would you use a conveyor? We talk about fixed path versus flexibility and so on, those type of questions. Yeah.